So on to first the content that we missed last time. We were talking about, let's actually back up just a little bit here. So we were talking about this kind of stuff, right? Hang on, let me get back just a little bit more. Where we had some data like this, and we were talking about fitting these 3 different models, right? And then from there, we said, so we had split the data previously. So from there, we said, well, we could clean up the data a little bit, and then we could split it like this. So we have our data, and we're splitting it by content area. And then from there, we could use map to loop through this split content thing and apply our model. And we save all of that in this one object called M1. We do it again with a slightly different model for M2 down here, and again for M3. So we have these 3 different objects, each representing all of the models for each content area, right? And then an alternative, though, that we talked about was using this nest function from, I think it's from dplyr, which allows us to create a list column. Okay, so we just group by something, in this case content, and then we nest it, and what we get is 1 row for each thing that we grouped by. So we could group by multiple variables here still, and we get 1 row for each thing that we group by, and then over here is all of the data for that grouping. Okay, so this cell of the list column is all of the data for ELA, whereas this cell is all of the data for math, etc. Okay, and what this allows us to do, so if we look into it, it looks just like the split, but what this allows us to do is to actually add columns to our data frame, including potentially our models. So we walked through fitting a single model and pulling the coefficients out of it, right? But we could also fit multiple models like this. So instead of having those 3 different objects and this list that we're all kind of working through, this allows us to kind of package it all together in a single data frame, which is just helps a lot with organization and keeping things straight, specifically when it comes to doing things like this next step, which is comparing 2 different models, because we could compare 2 different models with like our objects, which is basically what this is, but we could also loop through M1 and M2 concurrently and compare them all together. So we know, because they're kind of all matched up, that everything is going to be fit here as we expect. So this is just essentially a way to keep things a little more organized, okay? And then from there, we talked about, okay, well, now we could actually pull something out of there. And I talked about possibly writing a function to do that for you. And then we end up with a data frame like this, where we have the models, and then we have this ANOVA objects that is the comparison between 1 and 2, and then this is the p-value for that. And then I didn't talk about this. There is an alternative way to create functions with this compose operator, and compose is kind of interesting. I'm going to just talk about it very briefly here, and then I won't probably talk about it the rest of the term. You are welcome to use it if you'd like. I think it's kind of neat. I honestly have never really used it, but I think it's kind of neat anyway. Okay, so what compose does is it's essentially a shortcut for writing a function. So instead of saying function x and then the curly braces and whatever, you just say compose, and then just like in Pmap, you can use the tilde and .x syntax. Okay, so you use tilde to get yourself the .x, and then you can put the .x in there anywhere you want. Okay. And then you now have a new function, which in this case, I'm calling center, okay? And so you can use that function just like you would any other one. So here I have bill length, and I'm passing that to center. And then when we look at the first 5 values of that, you can see it's here. So centering, right, it's gonna make the mean 0 and the standard deviation. Well, no, it's not gonna do anything to the standard deviation. It's just gonna subtract the mean from each observation. So it's mean centering. And then here, I'm checking that it works. What's the mean of it, and round it, and yes, it's 0. Okay. So we could use this compose syntax instead if we wanted to write a function to get a p-value extractor. because remember, this is basically the code that we used for one ANOVA object. So instead, we just use compose, and then we use a tilde, and .x becomes our placeholder for any ANOVA object, okay? And so then we can use that. This is now a function I'm calling p. I map through comp12, this thing I fit up here, and I pass it p, and we get the same p value, okay? So this is just very quickly, that's another way to write functions. We will spend a couple of, I think the next 2 full weeks, and then really throughout the rest of the term, we will talk about writing functions, okay? So this is a big topic in the course, and this is just a very quick introduction. So don't worry about it if this is not like super clear. All right. So that's one way to do it. What we didn't get to, and one of the things you will need to do for the midterm, is to do it slightly differently. Okay. The way that I've showed you so far is the group by, nest, mutate, map method, right? You're going to group by some variables, then you're going to mutate to create a new, or then you're going to nest to create the list column. Then you're going to mutate to create a new column in that data frame. And then you're going to map through that list column to compute the new thing in your data frame. Okay. Alternatively, if you're doing everything in a data frame and you're never ever going outside of the data frame, there is this alternative approach that dplyr provides us, which is a row-wise operation. Okay. So here's a very quick example. Right? I create a data frame right here. And if we look at this data frame, it's X, 1, 2, Y, 3, 4, Z, 5, 6. Okay. And so I might want to compute basically the row means. What's the mean of each of these? But if I just say M is equal to the mean of X, Y, and Z, what ends up happening is these columns right here all end up getting collapsed into a single vector, and we're computing the mean of that vector. So what we're doing actually is computing the mean of all of this, 1, 2, 3, 4, 5, 6. Okay, and whatever that value is of length 1, so it just gets repeated for every single row of the data set. So we get 3.5, which is neither the mean of this row or this row. It's the mean of the entire square or rectangle there, right? Instead, what we can do is we can use this row-wise function. And then when we do mutate, notice it's going to actually give us the correct means. So M in this case now represents the mean for each row. Okay, so that's fine, but it goes much deeper than this. Okay, row-wise fundamentally changes the way that a data frame behaves. And so therefore, if you want to conduct operations row-wise, you should have row-wise in there, but you need to ungroup after you want it to not do that anymore. Okay, so a very common set of code is you would go row-wise, mutate, ungroup. Okay? You can also add groups to your row-wise operation. So here's a very quick example where I'm saying group by name and then summarize, okay? And so in this case, basically this, whatever my grouping is going to be there just like any other group by summarize. That variable is going to be there. And then I'm getting my summary, which is actually just the row mean in this case, okay? But as I said, this can get much more complicated. And because of that, it can be much more useful. What we can end up doing with this is essentially the exact same sort of stuff that we're doing when we're doing all of that looping with map and everything, okay? But we don't have to actually do the loops because now everything is actually conducted by a row, okay? So for example, here is a data frame with a single column called var, which is a list. So it's a list column of 1, 2, 3, and 4, 5, 6, okay? So from df, I can mutate and say, what's the length? And I would say map int, so to say, give me an integer back. For var, what's the length? Okay, so it's going to loop through each element of var and give me the length. So I should get 1, 2, and 3, right? Because this is 2, 3, and this is 4, 5, 6, right? So that's 3 elements long versus 2 versus 1. And that's what I get. Alternatively, we can use row-wise to get the same thing. So even though we have a list column here, right, we can just say row-wise, and then I say, give me the length of var, okay? And because it's in that row-wise operations, it's going to be looking within each row. So even though it's a list column, it doesn't actually matter. You can just say var, give me the length of var, and it will tell you the length of it, okay? Because this ends up being such a helpful operation, dplyr also gives you another helper shortcut, which is called nest by, okay? And nest by works just like nest with one exception, which is it's going to group by those variables and then create the list column, and it's going to put it in a row-wise data frame, okay? All at once. So it groups by those variables, it nests after that, and then it puts the data frame in a row-wise framework, okay? So for example, when I take D and I say nest by content, notice this looks basically like it did before, except it says row-wise content, okay? So now any operation I do on this data frame will be conducted by row, okay? Any questions so far? Okay. So we just learned, but I'm going to actually skip over this because you guys don't have this loaded, but you will have many opportunities to practice this stuff later today, okay? But given what we just learned, we could fit a model just like we did before, where it's theta primary. So primary is the predictor of theta, and we're going to try to do it not using per. Okay, so we're going to use this row-wise approach. And what we do is we take D and we nest by content, right? That's what we had in the previous slide. And then I say mutate M1 is equal to, well, what's the output going to be? The output is going to be a list, right? So I actually want the output to be a list column. So I just wrap the whole thing in list, and then I just pass the formula like normal. But notice I say data equals data. Why is that data equals data? Data equals is the name of the argument, right? But then I have to pass it the thing that I want it to supply. When I say data, it's passing it this column. Because that column is in a row-wise framework, it's going to pass it this data frame for ELA, this data frame for math, etc. Okay? And what we get back is this list column with all of the models in it, just like we would have gotten with group by, nest, mutate, map. Okay? So we can extend this further to extract the coefficients. So here I say coef, and again, I'm saying list because there's more than one coefficient, right? This one has 11, this one has 12. Unless it returns of length 1, you have to wrap it in list, basically. Okay, so wrap it in list unless it returns something of length 1. Well, we might want to return something of length 1, right? So here I'm saying, okay, give me just the intercept. I have M1 here, which is just my list, right? My list with all my models. And then I'm saying intercept is equal to coef of M1. So that's this one, right? Getting the coefficients from there. And then I'm saying, give me just the first coefficient. And that gives me this. Notice I do not have it wrapped in list this time because it's returning something where each iteration, it's returning something of length 1. And furthermore, each of those return values are of the same type. They're all of type double. Okay? Questions?
What happens if you don't wrap M1 in the list?
If you don't wrap M1 in the list, you will, I believe, just get an error. It just won't work. Other questions? Okay. So using this approach, we can fit all the models just like we did before. List, 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 data equals data on all of them. We get them like this. And then I showed this before, but just to reiterate, because I think this is quite important. One of the things that's super nice about this approach, this data frame sort of approach to with list columns, is that it's just a data frame, like any other data frame. So even though you have list columns, you can apply all of your dplyr magic that you've learned from previous courses to work with this data frame. So we can pivot longer, for example, where we're grabbing M1 to M3, putting the names to model, right? And the values to output. At this point, this data column is pretty useless. We don't really need it, but we do need all of these outputs, right? And then from there, we can do something like extract the R squared, where I'm going to say map double through the output and give me the summary $R squared. So again, this is where like I wouldn't know necessarily how to pull the R squared from an LM object just out of nowhere, right? I would fit a little teeny LM model somewhere else, and I would work with that to figure out how to pull out the R squared. Once I have that, I just basically bring that into here and change it from whatever the object was to tilde dot x. So dot x is going to be my sort of placeholder for each of them. And then because I'm using map double here, I'm getting this. Notice this is not a row wise one. That's why I'm using map double. But then I get all these values. Then I can plot it, etc. Okay. Any questions on any of that? Okay. Unnesting. I honestly can't remember. Did we talk about unnesting last time? I don't think we did we? Okay. So very, very regularly, you will want to unnest. Okay, so you nest so you can do some operations, but then you might want to unnest after that. Okay, this is really common. We'll see more examples of this later today. We saw one example actually of how I did that in the extra credit part of the previous lab. Okay, so let's say we want to plot the coefficients from a model. So I don't know why sometimes this thing doesn't work. So I might want to use the tidy function from the Broom library. I've mentioned Broom a little bit in the past. This is not a statistical modeling class, right? So we're not going to really focus on this. But basically the idea of Broom tidy is that you can take almost any model, like it's most models that you can fit in R, there's a tidy method for it. So you say Broom tidy on the model, and it returns to you a nice data frame that has all of the output that you want from the model. So again, you can use dplyr and ggplot and all of that stuff with the model output in a very friendly way, rather than having to dig through that list to get the stuff that you want. Okay, so what I can do is I have my models that I fit before. I pivot longer, just like I did before, where I have M1 to M3, M1, M2, M3. But then I can mutate with tidied. So I'm creating a thing called tidied, right? Where I'm going to map through the output all of these different models, and I'm going to apply the function Broom tidied. Okay, so what I'm getting here is this is the actual output from the LM model, and this is a data frame that has most of the good stuff that we want from that model. Okay, and this is a tibble, and it's a tibble for all of them. Okay, so what we can, or here's the equivalent through a row-wise approach. So I just say row-wise, and then tidied. I just put output here instead of, so I don't have to deal with the tilde and the dot x, but I do have to wrap it in list. Okay. So what I want to do here to get all of them is I'm going to select, I'm going to take mods. This is old code. That should be pivot longer. Here's the mutate where I'm tidying. And now I'm just going to select content, modeled, and tidied. Okay, so I'm going to select content, the actual model, M1, M2, M3, and then this tidied list column. And then I can just unnest it. Okay, and then through that one, couple of lines of code, we now have a single data frame that has 841 rows and 7 columns, and we get all of the coefficients basically from those 3 models across all content areas. Okay. So we can look at how they change, how the coefficients change. This is not a very good plot, but it was just something I put together quick. So basically that's like a whole bunch of stuff that we can do very efficiently by using looping, right? But the last bit of this, and this is just kind of to illustrate how powerful this framework is, at least from my perspective. This whole time we've been working with content. We have to fit different models by content area, right? But really, we've kind of been fitting the wrong model the whole time because we've been ignoring grade. And this is statewide testing stuff, which means that each grade is a completely different group of kids. And so we probably want to actually analyze it by grade and content area separately. Okay, so all we have to do is change the grouping factor. That's it. The rest of the code stays exactly the same. And so if you're building up your code base and you're doing a good job of it with doing things like this, with building it through functional programming and sort of trying it as best you can to adhere to the mantra of don't repeat yourself, right? Not doing a lot of copying and pasting of things, then you hopefully should end up in a situation like this where you're doing something like this and then you take it to the people that you're presenting it to and they're like, oh, we actually need this by grade. And they'll probably be like super apologetic, like, I'm sorry you had to do all that work and now it's like the wrong model, you got to go redo all this stuff. And it's like, no, I just need to add grade into my grouping factor and rerun stuff. Group by content and grade, and then rerun it all, and there you go. Okay, the rest of the code is the same. Okay, so real quick summary, and then we're going to move on to the content for today. List columns are super powerful, really flexible. They do help you stay organized, I think. Working in a data frame also has other benefits like being able to use your dplyr tools. I really strongly believe in learning looping, which is different than learning the row-wise approach. However, they are accomplishing the same goals, okay? The reason I say that I really believe in looping is a couple of things. One, you very well may find yourself outside of this class working in a language other than R. If that's the case, row-wise is going to do absolutely nothing for you, but understanding how looping works will be very beneficial, okay? Loops happen in every single language, right? So like a for loop is a for loop pretty much in every language. There's slight differences, but they're pretty much the exact same. And the main thing is understanding the logic of the for loops or lapply or map or whatever. Okay, so if there's one thing that you should focus on with your learning, it's understanding the concepts of what's going on, and it doesn't matter really as much which one of these different ways that you use it. Okay, so if you do use row-wise, which I will obviously be encouraging you to do because I have that as part of the homework, is to do it with map and then redo it with row-wise. Just remember to ungroup when you're done so that it's a normal data frame again. Okay. All right. That's it. Yep.
I'm a bit unclear on what's the purpose of nest and unnest.
Yes. Okay. So nest takes, so the question for Zoom is the purpose of nest and unnest. Okay. So nesting is going to reduce your data frame down so you have a row for each grouping and then all the data for that grouping, right? Unnesting does the opposite. It takes that list column and it expands it out into a normal data frame. Okay, so for example, in the what I showed with the models, you would nest it so you have all the data for one content area and possibly content area and grade, right? Then you can loop through that to fit every single model that you want. But at that point, you can just drop that list column for data. But you might create a new list column like for all the tidied data out of that model that you fit. So then you could actually drop the model list column, and then you would unnest to get all of your coefficients and everything. Yep, great. Any other questions? Okay. All right. So moving on to the content for today, we're going to talk about parallel looping, which we already actually saw a very small preview of when we were comparing models with ANOVA. Okay. We will also talk about a bunch of looping variants. Okay. And the first part of this lecture is going to take quite a bit longer than the second part. So I had the break in here originally in between those two parts, but that might mean we're not breaking until like 3 o'clock, and then we're breaking and then come back for the last 45 minutes or something like that. Okay, so so I'll just kind of check the time as we're going through, and if we haven't taken a break by like 2:30, then I will just do that. If we happen to end up with extra time at the end, that will just be for you to work on the midterm with me here. But I'm not sure if we will or we won't. Okay, so the agenda for today is we're going to discuss map 2, which we actually saw already with ANOVA, and Pmap. Okay, and these are different ways through the map family anyway of doing parallel iterations. So instead of looping over one vector, you're going to loop over 2 vectors with map 2, or 3 vectors or 4 vectors or 5 vectors all at the same time with Pmap. Okay. We will also talk about a function called walk, which is very, very similar to map with one exception, which is basically you apply walk when all you want is the side effect. Okay, which maybe doesn't make sense right now, but hopefully will by the time we get there. We'll also talk very briefly about modify, which again is quite similar to map, but has differences on its output. Safely, which is very different from map. It's a completely different thing. And reduce, which is also quite different. And I had a hard time kind of coming up with good examples for that, but I do think it's a nice function. Okay. So the things you should be focusing on through this is the differences between map, map 2, and Pmap. Okay, that's the first one. And then understand when you should be using walk or walk 2 or pwalk instead of map. Okay, because functionally they will do basically the exact same thing, but what you actually see might be different. Okay, similarities and differences between map and modify. Again, they're super similar, just differences on their output type. And then be able to use safely, specifically for, I'm going to show you one way to use it to diagnose errors. Okay, but also understand situations when it might be helpful to use, specifically if you're doing anything on the web, working with APIs, working with scraping data straight from a website, safely is going to be really, really helpful for you. Okay. And then collapsing or reducing lists with per reduce. I also have base reduce there. They're like essentially the same thing. I don't actually think I have slides on base reduce though. So I put it up there, but I don't think I actually got to it. So, but if you're interested in it, let me know and we can talk about it. Okay. So this is the same sort of schematic that I introduced from map. The difference is we now have 2 vectors that we're looping through. Okay, so this is like an orange one and a blue one, right? And so these would be like 2 different arguments, say, to a function. And then you have f, which is the function you're applying. And then the yellow is just additional arguments that would be passed to f, like na.rm equals true. Okay, so what map2 will do is it will loop through these and it will apply this function to each of these, and then it will just append this to each of them. So notice the yellow does not change throughout here. Okay, same yellow because it's the same arguments all the way through. Okay, whereas here the orange and the blue, these both do change, but it's changing by row. So one row is getting like not really rows, but you know the indexes, like the first index of each, and then the second index of each, and then the third of each, etc. Okay, so that's what map 2 is doing. It's walking through, so this is what we use it for with ANOVA, right? It's walking through the first model and the second model, lists of models, and then it's applying ANOVA to each of them, ANOVA M1, M2. ANOVA M1B, M2B. Okay. So we'll go through a few examples. I'm going to go through some basic simulations, which is kind of just the theme we've been on, right? But then I'll also do some plotting, okay, to show you how to specifically create plots where you're varying the title of each plot to match the thing. Okay. So simulation, we'll start out here. Let's say we're going to simulate data from a random normal distribution. So that's that R norm function. And I want to vary the n from 5 to 150 by increments of 5. We've done this in the past. But I also want to vary the mean from -2 to 2 by increments of 0.25 for each n. Okay, so that's one of the important parts. For every n that I have, I want to vary this mean from -2 to 2. So I want it -2 to 2 for 5, -2 to 2 for 10, -2 to 2 for 15, etc. Okay, so how do I get all those possible combinations? In R, there is a really helpful function called expand.grid. Okay, and what it will do is exactly that. You give it 2 vectors, and it will give, or 3 vectors or 4 vectors, however many you want, and it will expand them out so you get all possible pairwise comparisons of them. So here's a very, very small example. I have these integers 1, 2, 3, and I have these letters A, B, C. If I use expand.grid on ints and lets, I get 1, 2, 3 for A, 1, 2, 3 for B, and 1, 2, 3 for C. Okay, so that's what it does. Bonus, it also turns it into a data frame. So that's really nice for us because we like data frames. They're easier to work with, right? So please follow along for this part. I'll give you like 30 seconds to get R up and going if you don't currently. I'm going to be asking you to follow along a lot throughout here. So please do get set up. There's going to be a couple of different challenges and stuff that we'll do as we go through here. Okay, so it should look like this. One thing I want to point out is when I'm using expand.grid here, notice that I've given them names. So n is equal to this, and mu is equal to this. And then when I look at conditions, that's the variable names. Whereas back here I did not give them names, and we just get var1 and var2, just generic names. Okay, so if we want better names, you can name them in your expand.grid over here. Okay, and so you can see here's the n, 5, 10, all the way to 30 for -2. And then when we go all to the way to the bottom, we got 125, 130, all the way up to 150, where it's 2. Okay, so we have 510 rows, which gives us all of the possible conditions where the n is ranging from 5 to 150 in increments of 5, and the mean is varying from -2 to 2 in increments of 0.25. Okay, now we can simulate. Okay, so what we're going to do is instead of using map, we're going to use map2. Okay, so I'm going to call map2. That means I'm going to feed it 2 vectors to iterate over. The first is going to be n, and the second is going to be mu from my conditions data frame. Okay, then I'm going to use my tilde. And what's nice about map2 is map gives me .x when I use the tilde, right? Map2 gives me .x and .y. Okay, so .x refers to this first one, and .y refers to this second one. So then I just say R norm, n is equal to .x, and the mean is equal to .y, and I'm setting the standard deviation at 10. Okay, so the standard deviation is going to be set at 10 for all of them, but the n and the mean are going to be different for each iteration. And those are coming from our conditions data frame. Okay, so back here, we saw this was 510 rows. And sure enough, when we look at the structure of our sim1 output, we get a list of length 510. Okay, it is a list because I used map2, right? And in this case, it actually has to be a list. But map2, just like map, also has underscore double, underscore int, underscore LGL, and underscore CHR versions of it too. Okay. Slightly more powerful, in my estimation anyway, is we can actually just add this list column as a new column on our data frame. Okay, so we have this conditions data frame. We can pass that to as underscore tibble if you want. You actually don't have to, but the way the data frame prints is much nicer if it's a tibble with a list column than it is if it's a normal data frame with a list column. Okay, then I just say mutate sim, or whatever I want to call this column, is equal to map2, and then I just supply the rest, right? N and mu, the things I'm looping over, which are the columns here, and then tilde r norm dot x and dot y with a standard deviation of 10. Okay, and I get that list column. Why is that so much more powerful? Because I can unnest it, right? I unnest that sim, and now I have a beautiful data frame that has everything that I want, right? Questions on that? Okay. The challenge now, and your first attempt at row-wise, is to replicate exactly this. Okay, so we just did it using what I think is probably the more familiar, more comfortable approach to you, because that's what I've lectured on mostly, which is mutate. And actually, in this case, I did not have to group by nest, but we did use map2. Okay, so the challenge for 3 minutes is to try to do the same thing, except use row-wise, which means you will not have to use map or map2. Okay, so that's a bit of a hint. 3 minutes, give it a go. Okay, here's what I'd like you to do now. Give me a thumbs up if you were able to get it and you felt successful. Thumbs down if not, or somewhere in the middle if you're somewhere in the middle. Those of you on Zoom, you can just use your emojis if you want. Give me one of these. Okay, all right. That's about what I would have expected. I didn't see any Zoom emojis, so. All right, Zoom people are not participating. Okay, so this is how I would have done it. Thank you, Ksenia. All right, so we have conditions, and we're going to pass that to row-wise, and then I'm going to mutate and say sim is equal to list. Okay, that's going to be very important because the output from each iteration is going to be of a different length, right? And then I just say r norm. Notice I don't have to have the tilde or anything. I'm just saying n and mu. Why is it like this? Because I'm going through, when I come back here, right? I'm going through this as each row, right? So this is the first iteration, this is the second iteration, this is the third iteration, etc. Okay, so that's all we have to do is just n and mu, and then standard deviation is equal to 10, and then we would unnest sim. Okay, questions on that? Okay. What if we wanted to vary the standard deviation too? Well, then we would use Pmap, which we will get to, but not right now. So, second example, we're going to walk through creating a plot, and we're going to vary the title of the plot in each one. Okay, so here's the data. Please follow along. This is data that we used last class called 538, and we're going to specifically use the Pulitzer data from there. So I'll give you 30 seconds again to load 538 package and then get the Pulitzer data up. All right. Okay, so it should look like this. You've got the newspaper and then some information about that newspaper. We're going to prepare the data. You can just copy this with that button if you have the slides pulled up to do this. Otherwise, you can copy and paste it from the PDF, or you can just type it out real quick. But basically, we're going to select only newspaper and start any of the columns that start with num. Okay, Then I'm going to pivot longer. I'm saying minus newspaper here. So that means basically we're going to include everything in the pivot except newspaper. I'm going to put the names to year range and the values to n. Okay. And then I have this names prefix is equal to num finals. Okay. And so that's going to end up here. And then I'm just going to say mutate range, string replace the underscore for a dash on the year range. So we get 1990-2003 instead of 1990 underscore 3. And then I'm going to filter out where the range is 1990 to 2014 because it's split into those two sections here. So I don't want it split out twice and then the whole range also. So I'm just doing the two bins separately. Okay. And so it looks like this. I'm actually thinking as I'm looking at this, that this N is the number of finalists each newspaper had for the Pulitzer Prize, but I was saying that was the number of winners they had. So probably off on the title here, but that's okay. All right. Let's say we want to create one plot, okay, for one newspaper is what I mean. Okay, here's how I would do that. First, I'm going to subset the data so that it's just one newspaper. I'm calling this WSJ for Wall Street Journal. Okay, I'm taking Pulitzer and I'm filtering where the newspaper is equal to Wall Street Journal. Then from there, I'm just creating my ggplot. Okay, this looks like a fair amount of code. Most of it is just styling. Okay, so what I'm doing is I got Wall Street Journal. I'm putting N on the x-axis and year range on the y-axis. And then I'm saying geom call where the fill is equal to N. Okay, then I'm going to say fill scale fill distiller, right? And then the reason I'm doing this mostly is actually for this part right here. I want that color scale to stay the same across all of them, regardless of what the total N is. So the limits are of this color scale are going to be 0 and whatever the overall max of Pulitzer N is. Okay, so not Wall Street Journal, but the overall data set Pulitzer N. And then scale X continuous. I just want the X axis to also stay constant across all of them. So that's what that's about. Guides fill equals none. That's removing the legend. And then I'm putting some labels on there. Okay, so this looks like this. Okay, so here's one plot for the Wall Street Journal. Okay, so notice this is filling into a purple color. The higher up it goes. Okay. All right. So now we've been able to do this for one plot. And what we want to do is actually create that plot for every newspaper. Okay. So I'm creating a nested data frame here, which I am calling by newspaper. Okay. What I do is I take my Pulitzer and I say group by newspaper and then nest. Okay. And so my by newspaper looks like this, where we have one row for each newspaper, and then we have all of the data for that newspaper. Notice in this case, the data frames are actually only 2 rows each time. Okay. Now, 3 minutes, what I would like you to do is take this code back here that I used to create one plot and take this nested data frame here and try to create all plots. Okay, create a plot for each newspaper. That makes sense? Okay, 3 minutes, give it a go. All right, same thing as before. Give me some sort of thumbs up, thumbs sideways, thumbs down indication of how you felt on that one. Okay, so that one was a bit more challenging, and that's okay. This is how I would have done it. This, to start here, I'm not worrying about trying to change the title either, okay? Because back here, notice it says Pulitzer Prize winners, Wall Street Journal. I'm just gonna ignore that for this particular moment, okay? All I'm gonna do though is I'm basically gonna copy all of this code, right? And then I'm going to put it in a map, but I'm going to pass it the data and then tilde and I can use the curly braces to kind of keep things contained. So here's where the plot ends, if I want, right? And then I have the rest of it down here, okay? This actually should be .x right there, but it works without it too, apparently, because it's the first argument. But you could put .x right there, comma, for the data. ggplot data arguments, right? Does that make sense? Questions? Okay. It looks like a lot of code, but again, most of it is just styling code. Did you have a question?
So yeah, sorry, just saving like the whatever features of the plot into a column. Plot.
Yes. So it will look like this. So we have a new column for each plot, and ggplot actually stores a whole bunch of stuff when you create a plot, and all of those features are stored there. So from there, you could look through that to save each plot if you wanted to, or you could look at a couple of the plots or whatever. Okay, so this is how we would do it if we're just using map, but that's not actually what we want, right? We want to vary the title as well. We want it to say, you know, to vary for each newspaper. So instead, I'm going to use map2 instead of map, and I'm going to loop through data and newspaper. This time I actually have my .x for my data, right? And then for my title, I'm using a function called glue here. You could also use paste 0 or paste, okay? Glue is just there's some reasons why it's nicer in some cases. In this case, it really probably doesn't make much of a difference. But the way that glue works is you have a single string, right? So this is just one string. But within that string somewhere, you put these curly braces, okay? And then in those curly braces, you can put R code, and the result of that R code will be rendered in the string at that location, okay? So you could easily do paste 0 here, and that would be fine. I'm just using glue here to just show you another way to do it, basically. So here I'm saying Pulitzer Prize winners, and then in curly braces, .y. So whatever the .y is, which is newspaper, it's going to loop through that and insert it in for each of them. Okay, so I already showed this, but this is what the resulting data frame ends up looking like. We have all the data, but now we have all the plots for them. Okay, so we could look at a couple of them if we wanted to. Here I'm looking at the first one, that's USA Today. It's very low, right? For plot 2, that's Wall Street Journal. We already saw that one. Plot 3 is New York Times, so it's way up there. And then Los Angeles Times, it's up there a ways too. Okay. And again, these x-axis say total number of winners, but that probably actually should say total number of finalists, I think. But regardless, that's how we create it. And notice that the title is changing for each of them, as well as the plot is changing for each of them. Questions? Okay. Okay. New challenge. Guessing you can probably guess where this is going. Can you reproduce that, but now using a row-wise approach? So same exact thing, using all the same code for the plots, I mean, but just using row-wise instead of map 2. Okay? 3 minutes, give it a go. Okay, very quickly, I want to go back here for just a second. This code should work. However, I believe this code will not work. I think you need the .x right here after ggplot. I'm just missing it there. But this code should work. Okay? So, back here. All right, check-in time. Give me your thumbs up version. Where are you at? Okay. All right, so that's pretty good. Okay, this is how I did it. I said nest by newspaper instead of group by newspaper nest, right? Pulitzer nest by newspaper. Then mutate plot list, right? I'm going to wrap the whole thing in list. And then I'm going to say ggplot data because I have that column called data, right? And that's going to be the thing I'm kind of looping through. And then here in my glue, I just put newspaper there now instead of .y. Okay, and then you can't see it down here, but it ends up being the same thing. All right. Questions on that? Okay. Why don't we go ahead and pause there to take a break? And when we come back, we will talk about Pmap. Okay, so it's 2:04. Let's be back at 2:10. Sound good? All right. Okay, so let's say we've now mostly through the term talked about iterating over a single vector and applying a function to each element of that vector. We've now just introduced iterating over two vectors and applying a function to that takes each, like the function takes two arguments and each elements of those get cycled through, right? What if we want more than two vectors? That's where Pmap comes in. Okay, Pmap works a little bit differently in that the first argument that you supply it is actually a single vector. Okay, that single vector though is a list. It's always a list. Okay, so you give it a list with however many arguments you want to pass it. It could be 1, it could be 2, it could be 76. Doesn't matter. Okay, and then it's going to cycle through them like this. So this is an example with 2. So this is one where map 2 could be used, but basically notice that this whole thing is sort of surrounded. So these are two basically elements of the list, and they get passed to the function like that. Okay, so back to our simulation example. We're going to vary the n from 5 to 150 in increments of 5. For each n, we're going to vary the mean from -2 to 2 in increments of 0.25. And for each, well, that says standard deviation. That's a typo. For each combination of these, we're going to vary the standard deviation from 1 to 3 by increments of 0.1. Okay? So generally, the process here is going to be the same as what we did before. We're going to start off by creating a data frame that has all the possible conditions that we want to simulate through. Okay? So I'm using expand.grid. I'm going to give it my sequence of n's. I'm going to give it my sequence of mu's, my averages, and I'm going to give it my sequence of standard deviations. Expand.grid will then cycle through these, compute all possible pairwise all pairwise comparisons, and then create a data frame that has all of these. So now we have 10,710 rows from these three conditions, right? Three sets of conditions. All right. Now we're going to loop through all of those conditions and apply R norm to change each of them. So we're going to do it like this. Okay, so I have Pmap, and as I just said, the first thing I'm going to pass it is a list. Okay, the list then ends right here, and there's several different ways that you can use syntax from Pmap. So I'm illustrating one here, and then I'll show you others here in just a second. Okay, so I'm calling these, I'm actually naming the elements of the list that I'm passing it. The names I'm giving it are number, average, and stdev. Okay, and those are just going to be the elements of my data frame that I just created with expand.grid. Full conditions n, full conditions mu, and full conditions sd. Okay, then down here, I write a function that takes those three named things as arguments. Okay, so very importantly, in this sort of an approach, if I call this thing number here, I should call it number here. Okay, I call this average here, I should call it average here, and stdev here is stdev there. Okay, and then you write your function and you just fill in where they go. So n goes to the number, mean goes to the average, and sd goes to stdev. Okay, and then when I go through that, it's going to basically iterate through each of these row-wise. Okay, and then it's going to draw the samples from those, and we get a list in return of 10,710, length 10,710. Okay. An alternative specification is we can pass the list just like this, with or without names, it doesn't matter. But instead of doing our .x and our .y, we don't know how many there are going to be, right? It could be that we actually need .x, .y, .z, .xx, .zz, whatever. I don't know what you do after z. Could go back to a or numbers, whatever. So instead, they just do .1. That refers to the first one. .2 refers to the second one. .3 refers to the third one. And it goes all the way to .n, right? However many elements you have that you're looping through. Okay, so I call rnorm on that. And notice though, to get these dots to work, I have to use this tilde. Okay, so the tilde syntax with Pmap gives you the option to use these .1 to .n. Whereas back here, I'm not using the tilde, right? I have explicitly said function and then given it the named arguments that I want to use within my function. Okay, if you don't do that, if you use the tilde, then you need to use the .1, .2, .n. Okay, questions on that? All right, even simpler, but as I've said here, maybe a little too clever. A data frame is a list, right? And so we could actually just pass it the full conditions data frame. And then when I say .1, that's going to be the first column of that data frame. .2 is going to be the second column of that data frame, etc. Okay. All right. So list column version. This is probably how I would actually do this. If I were to conduct this simulation, I would change it into a tibble first so that the printing is nicer, and then mutate, create a new column called sim, and then I'm going to pmap where I'm going to list n mu and stdev and mu st, not stdev, just sd, right? And then .rnorm 1, 2, 3. Okay. And then we get this simulation for all of those. And then what happens next? We unnest and we get our full data frame with all of them. Okay. All right. That was the previous version. Now you get to try with nest by. All right. Or row wise is probably what it actually should say. Not nest by. Go ahead. All right. So this is how I would do it. Full conditions, taking the full conditions data frame. I'm going to pass that to row wise. So that creates a row wise data frame. And then I can mutate to create the new object called sim, where I'm going to just say list rnorm and mu sd. Okay. So in this case, the syntax is quite a bit more brief, and then we'll just unnest. Okay. The main thing that I think is tricky with this nest by or row wise approach, the main thing usually is remembering to wrap the whole thing in list. Okay. But from there, within this list or within whatever you're doing, you just have to refer to the columns of your data frame where you want them to be. Okay. And then because I've wrapped this whole thing in list, I now have to unnest it to get back the full data frame. Any questions on that? Okay. All right. Now we're going to go back to our plotting example again for Pmap this time. However, we're going to also add a caption to our plot that has the total number of Pulitzer Prize winners across the years. Okay. So first thing I need to do is add that column. So I'm creating a new column, which I'm just calling tote, which is just summing the N within a newspaper. Okay. So again, this is probably the number of finalists, not the number of winners, but whatever. Okay, so I have Pulitzer, group by newspaper, mutate, tote equals sum n. Okay, so this is just going to 1 and 1 is 2, 30 and 20 is 50, 55 and 62 is 117, etc. Clear? Okay, so now we have that. And now we're going to create a new column in our data frame that has the actual label that we want for our caption. Okay, there's other ways you could do this, but I think this is easier. All right, you don't have to do it this way, but there's this package called English, which I think is kind of neat. I've showed you this one other time, but we didn't really go over it. But it's just a package to convert numbers into English words. Okay, and so what I'm doing here is with Pulitzer, right? I'm saying mutate. I'm creating a new column called label. Okay, that label is going to be glued together this, which I'll go over in a second, total Pulitzer Prize awards. Okay, so basically this part is we're taking that tote column, okay, that total column back here to 5117, and we're putting that in English words. Okay, that's what this as.english function does. Then from there, I'm changing it to title case. That's what string to title is doing. Okay, so title case just means like the first word of every, the first letter of every word is capitalized. Okay, except for words like and of and those ones. Okay. So now my data frame, notice I haven't done anything with plotting yet, right? But my data frame looks like this if I just look at newspaper and label. So here's the newspaper and here's the label. So 2 total Pulitzer awards, 50 total Pulitzer awards. Although again, probably should say finalists, but whatever. That makes sense? Any questions? Okay. All right. Now again, I'm going to work with my Wall Street Journal plots, and I'm going to create one plot. And again, I just want to emphasize, this looks like a lot of code, right? But it's not really that much code. It's mostly styling of a plot. And as we all know from last class, styling of a plot can take up a lot of space, a lot of code, right? So with my Wall Street Journal, in this case, I'm calling it WSJ2. Okay, and I have Pulitzer, and I'm filtering to just Wall Street Journal. I'm taking ggplot, I'm plotting WSJ2. This part is all the same, except when I get to here. Okay, so the title is this part. I just have, I just have the glue in there right now, although I don't actually need to glue it, right? And then I have total number of winners, and then the Y is nothing. But then I also have this caption equals unique WSJ2 label. Why do you think I'm wrapping that in unique?
You have multiple of the same caption.
We have multiple of the same caption. For a row, we have 2 of them. Or for a newspaper, rather. Okay, so when I say unique, it's just going to give me the 1. So because for Wall Street Journal, right, if I just get Wall Street Journal, that's going to be these 2 rows. So I want just 1 label. I don't want 2 labels. Okay. Everything else clear there? All right. So here it is. We have Pulitzer Prize winners, Wall Street Journal, total number of winners, and then 50 total Pulitzer awards right there. Okay. All right. Now we're going to produce all plots. Okay. So we have Pulitzer. We're going to group by newspaper and label. Okay. And then I'm going to nest. So now we have newspaper and label and then all our data. So now I actually won't have to do that unique thing because I only have 1 label for each newspaper. Okay. So this is an instance where when I was working on it for just 1, I actually had to make the code slightly more complicated than I will when I'm working on them for all of them. Okay, did you have a question? Okay, you just look like you did. Okay. So here we go. Now I'm going to create it. So I'm calling it final plots by newspaper label. That's what I called this back here, right? I'm going to mutate, I'm creating a new thing called plots, where I'm going to call Pmap, and I'm going to pass a list that has the newspaper, the label, and the data. All the elements of the data frame, right? All the columns of the data frame. So technically, I could just pass the data frame if I wanted to. Then I'll call ggplot. The first argument to ggplot is the data, so that's .3, right? Notice I have the tilde right here that gives me access to those .1, .2, .3. And then down here, I have my glue .1, and then my caption is just .2. Okay? And here we go. There's the first 4, just like we saw before. So notice here it says 85 total Pulitzer Awards. Okay, right here. Okay, questions on this? I know this is getting fairly complicated and it might feel like overwhelming. And maybe the plotting part is hard because the plotting feels like a lot of code. But what I'm trying to get you to concentrate on mostly is what is changing each time we're going through this. What do you build as sort of your template that you're going to loop through everything, and what are the few things that need to change as we're going through? Okay. All right. You go ahead and try to replicate with actually row-wise. Or actually, no, this one is with nest by. Okay. How successful were you? Give me a thumbs up indicator. Okay. So good. So I think the more you practice with this, the more comfortable you will get. I know it's kind of hard to be under these time constraints where I'm saying like 3 minutes and you're gonna go now, get it done. But hopefully you're at least getting the feel for it. It might feel a little overwhelming and difficult at this point, and that's okay. But as you work with it more and more and more, hopefully you'll start to build fluency and it will start to make more sense. Okay. So all that's to say, don't worry if you're not feeling super comfortable with it right now. This is how I did it. I'm not actually sure why I have this ungrouped to start, but I did. And then I'm going to nest by newspaper and label, and then mutate, wrap this whole thing in list. Okay. And then down here, I'm going to say Pulitzer Prize winners newspaper, and then caption is equal to the label, and then ggplot data. Okay. So you can see it's very similar in all of these cases. It's very similar to the map approach. It's just you're saying row wise, and then you're going to wrap the thing in list, and then you're just going to refer to the columns instead. Okay. So this ends up looking the same, basically. All right. Now, here's another very, very common use case for parallel iterations. Let's say that we've now created all of these plots, right? And they're specific for each newspaper, so we feel good about it. They have, the title for each of them, and they all have their own unique captions that have the same number of, they say the total number that they have, right? So if we want to actually save these plots in some directory that we'll use for something else, well, then we've got to iterate over at least 2 things, right? We've got to iterate over the plots that we created, and we've got to iterate over the paths that we're using to save those plots. Okay, so we're going to try this. We can do this with map, but there's actually a slightly better way to do this with map instead of map, the map family that we'll talk about in a minute. So so instead we'll do it a different way. But if we're going to do this, what are the steps? Like how would we start to do this? What would be the first step that we would do after we've created all our plots to actually save each of them to a directory? What would be the first thing that you would do? You could create a directory. Good. What would be the second thing that you would do? Create unique file names. Yeah, and what I would say actually to extend on that a little bit is rather than file names, I would say file paths, right? Because we want to have the full path to that directory that we just created. And then the final thing that we're going to do is what? Those of you on Zoom could participate too if you want to. Yes, we're going to use ggsave to save the plots. The only difference there is now we have a vector of file paths and we have a vector of plots. So we want to loop through both of those things together and apply ggsave to each of them, right? So we want to apply ggsave to each plot object and then pass it the path to where we want to save it, to that function, right? Because if we look at the ggsave function, we'll see that the first argument is the path and the second argument is the plot that you want to save. Okay, so that's how we would do this. That's the steps. What if we wanted to use nest by? Is that possible? Can we use nest by, do you think, to actually save the plots? Feels weird, right? Because nest by is a data frame solution to things. Okay. However, it is actually possible. So we're not going to take the 4 minutes for this, but I will just show you instead. Okay, so we can do this, and we're going to do just what we said. We would first create a directory. I left that step out of here, but then we're going to create the vector of file paths, and then we're going to loop through all the plots that we just created and the file paths, and we're going to save them all. Okay, so here's a quick example of how I would do it. Okay, I'm using fs in this case, but you could use the base functions if you wanted. So I'm using dir_create. The base function is dir.create. Okay, .create instead of _create. And then I'm creating a path. The reason dir_create is a little bit nicer in this case instead of dir.create. dir.create, the base function, will only allow you to create functions at a certain level, whereas dir_create will allow you to make less nested directories. So in this case, plots already exist, but if I didn't already have a plots folder, I could still run this code and it would create both the plots folder and a new folder called Pulitzer's inside that plots folder, all with this one line of code. With dir.create, you'd have to first say dir.create plots, then dir.create plots/Pulitzer's. Okay, so it'd take 2 lines of code. So it's not a huge deal, but it's a small difference. So we create the directory. Then we're going to create all of our file paths. So this is how I did it. And again, this is not like, there's definitely not one way to do this, okay? But I'm saying string replace all, or gsub is actually how I would normally do this, where I'm looking at the newspaper, okay, and I'm putting this to lower, okay? So I'm taking all of the newspaper names and I'm putting them all to lowercase. Then I'm finding all of the spaces and I'm replacing them with dashes. So for example, New York Times, all in like title case, right, would become all lowercase and it would be New-York-Times. Okay, so that's the files there, and that's just the names of the newspapers in lowercase with the spaces replaced with dashes. Then to create the paths, I'm going to say here, plots Pulitzer's, what I created up here, and then I'm going to glue files, all of these files, with .png. Again, I'm using glue all the way throughout these slides. Could also just do paste 0 files and .png. Okay, either way is fine. And I'm saving it as a ping. I could save it as a PDF or whatever, but in this case, that's what I'm doing. Okay, then if I look at paths, I get all of these different paths, and each one of them is going to be slightly different because it's going to be based on the newspaper that we have. Okay, so now if I want to do this as a nest by solution, as I said, it's slightly awkward, I think, because you're working with a data frame when it doesn't really make a lot of sense to work with a data frame, at least to me, just conceptually. But you can do it. So I have final plots, my final plots thing. I'm going to ungroup, and then I'm going to mutate to create a new column called path. Notice path is part of this data frame down here. It's just cut off, and so it's on. It says with one more variable, right? Path. So path is equal to paths. This thing I created back here. Okay, this is paths. I'm just basically adding it to the data frame. Now I'm saying select plot and paths. Here's the plot. There's the path. Okay. Now to save, this is the part that I think is fairly awkward, but it works. We go final plots, ungroup, because we were in a row. Wait, I don't know why I'm ungrouping there again. Not sure. Then I'm gonna. Oh no, this is all the same stuff as before. Okay. Okay. So I'm ungrouping because I was grouped by the newspaper and the label. So that makes it grouping by nothing now. And then I'm adding the path, and then I go to row wise. Okay. And then I'm going to summarize to save. Which again, slightly awkward, I think, but it works because summarizing is always going to be collapsing, right? So in this case, we're collapsing by row. Each row, we're going to summarize to ggSave, where the first argument is the path, the second is the plot, and then we pass additional arguments that we want to that function. Okay, and this actually works. It goes through all of them in our data frame and it saves them all. Okay. However, as I've alluded to multiple times now, I think this is awkward. This is not how I would normally do it, but it is doable. Okay. And so this is part of why I have mentioned before that I want you to be able to use NestBy, but I also think it's important for you to be able to use the map family, because something like this is really kind of tricky and neat for R, but it's not going to generalize to any other language. And it's only like a tidyverse solution. Okay. Whereas the other approaches like a for loop or for sure, but like the more functionals that we'll use in a second, those are more generalizable. There are other functions like that in other languages. Okay. Question? Okay. Anybody else have questions? Okay. All right. So just to wrap up on this section, because then we're going to move to the next set of things. Parallel iterations really increase the number of things that you can do, right? I would say iterating over two things is really common. Like I do that. I probably use map2 almost as much as I use map, right? I use it a lot. Pmap, I don't use nearly as frequently. I probably, if I'm using all of these 10 times, I probably use map 6 times and no, probably map 5 times, map2 4 times, and Pmap once. Okay, so Pmap is not as common. However, it is still a nice, useful tool to have in your bag. The NestBy approach can pretty regularly, I think, make things actually easier once you get the hang of it, because you don't have to use the tilde and the .x and .y syntax. You're just referring to the column names in your data frame. However, it's also less generalizable because you have to be within a data frame. You can't loop over anything outside of that. Okay. And so sometimes you can find these solutions like I just showed you with the saving, where you can kind of force it into the data frame approach, but it doesn't really fit. Okay. So in my view, learning both is worth it. Looping with per is really, really good. And I think it's preferable to the base functions for a couple of reasons. One, and probably the main one, is it's type safe, and meaning whatever you get back, you always know it's going to be that. You always know it's going to be a list, it's going to be of type double, it's going to be of type character, whatever, right? That's a really important thing when you get to building functions and things, okay? Which we'll start next week. It also doesn't have to be used within a data frame, and as I've alluded to many times now, it's more generalizable to other languages. At least the logic of it is. Okay. Okay, we're not going to do a break because we did that early. Although we can take a pause for a second before we move on. Does anybody have questions on sort of anything we've covered so far? It doesn't have to be specific to parallel looping, just sort of where we're at, how you're feeling about the term, about anything. Questions on anything here? We're feeling okay? Or what are you not feeling okay about, I guess, is maybe another way of phrasing it.
I guess just understanding when to use which of the looping functions.
Okay, so the question was when to use which of the looping functions. So this is very much a, so it does vary by problem, right? There's some problems where one is preferable to the other. However, in many cases, I think it is sort of stylistic and up to you. So for example, you could use a for loop, or you could use map2, and both will accomplish the job. And I don't think one is necessarily preferable over the other. I do actually, that's not totally true. I do think map2 is preferable because it puts the focus on the function that is being done, whereas the for loop is a lot of code to write for a little bit of looping, right? So functionals generally, like lapply, vapply, map2, are generally preferable, I think, to for loops. However, they both work. So if you feel really comfortable with for loops and you feel really not comfortable with map2, for example, you can use a for loop to do map2, and that's going to be totally fine. Does that help? But yes, recognizing use cases is a big thing, and sort of a huge part of this class is being able to look at a problem, break it down to a much smaller individual problem, and then soon write a function for that problem, and then loop that problem through all of your other pieces. Okay, and that part does just take time. And the more that you sort of think about looping and function writing and all that, the more it will start to become natural. But it absolutely takes time, and there's just no substitute for it. Anything else? Anybody on Zoom have anything you want to check in about? Okay, so we will move on then to looping variants. So I think we have now officially covered everything that you will need to do the midterm. However, the looping variants are required for your final project. So you'll have to use some of these, at least one of these. I can't remember exactly what I had in there, but some of these are required. You have to use at least one of these. Okay, so we have walk, which I've alluded to. I've talked about all of these. Walk, modify, safely, and reduce. Okay, so just a reminder about the learning objectives for this part, because it's been a while now since the start of class. Walk and map are super similar. So by the end of this part of the lecture, hopefully you'll be able to understand when you should use walk versus when you should use map. Okay, again, I would say 90% of the time you're going to want to use map. There's just a few use cases where walk is preferable. Understand parallels and differences between map and modify. Again, that's just about the output type, which I think I only have like 3 slides on that, but modify is nice. And then using safely to diagnose errors and other situations where it might be helpful. So I mentioned web scraping will show one example of that. And then collapsing or reducing lists with base or with per reduce, which is very similar to base reduce, but I actually probably won't do that. Okay, all right. So setup. Last time meaning a couple minutes ago, because these are old slides and I forgot to update that part of it. We talked about saving using that nest by approach, which was a little awkward, right? Instead, we'll do it now again, but we'll use walk instead. Okay, so what I would like you to do, oh, well, actually, I guess I'm going to talk about walk a little bit first, and then I'll show you what I would like to do. So walk is an alternative to map that works exactly the same as map. However, you use it when the primary thing that you want is what's called a side effect of a function rather than the return value itself. Okay, so a side effect, we'll talk about this more starting next week, although I don't focus on it too much because I don't think it's that important. But a side effect is anything that happens that sort of breaks this idea of purity in a function. Okay, so purity, very, very quickly, means that a function is called pure if it only depends on its input and its output. If it only depends on its input and it doesn't alter anything in the sort of what I think of as like the state of the world. Okay, so for example, if you call sys.time on your computer right now, that is an example of a not pure function because it will give you a different output every single time because the time on your computer is changing. So its output does not depend only on its input. Okay. Similarly, plots are not pure. Okay, so the plotting part of it is what's called a side effect. So anything that sort of violates purity is called a side effect. Okay, and they are not, like, a plotting function is not a pure function because it is altering the state of the world, right? An actual thing is being generated on your computer. Okay, similarly, like print even is not pure because it's printing something to your console. Okay, so that's altering the state of the world. All right, so when the primary thing that you want is the side effect, aka the plot, and not the return value, which if you're in a list would just print an empty list, then you want to use walk. So that's a lot of jargon to basically say if you're looping through and you just want it to show the plot each time and nothing else, walk is going to be what you want. Okay, you can check out this link if you want to learn more about it. So this is exactly what I just said. If you use walk, nothing will get printed to the screen, and this is except for the plot itself. And this is particularly helpful for our markdown files. Okay, so please do the following in the next 3 minutes. Create a new R markdown document, and then paste the code that we had for creating plots in a chunk there, along with all the libraries and stuff that you need and whatever data cleaning that you need to do. Okay, so while you're doing that, I will do it too. 3 minutes. Okay. Okay. Let me switch my share, or add to my share rather. Okay. So here's what I did. I just called it example, and then I said hello, and then I put 538, and then I have Pulitzer, all of my cleaning there, and then I'm grouping by newspaper, mutating, library glue, that should go up top. And then I have my by newspaper where I'm doing all of that, and then when I look at P, oops, maybe I didn't run it. Oh no, I didn't run this either. Okay, hang on just a second. By newspaper. That's going to be Pulitzer. Group by newspaper and nest. Okay, now that should work. And if I look at P1, oh, not P1. If I look at P, it's going to look like this, right? And then if I do P plot 1, it would print the first plot, which has almost nothing. And then P2, there's the second one, right? So that's cool. And then what if I wanted to actually now print all of these in my R Markdown document. So first of all, let's just knit this to make sure that it's working. I'll go to my desktop. And it's not because I need to go library tidyverse. Okay, knit. Okay, so that works, which we can see over here. Okay, so we have all of these warning messages and stuff which are annoying, but whatever, it all works, right? And we have hello up there. Okay, so good. Now let's say that I wanted to loop through this and print actually all of these plots. Okay, so I could just do something like this. I could go p plot 1 to 10. So I'm just going to do the first 10. Okay, watch what happens when I knit this though. Come down here. Notice I get this 1, 2, 3. See that? I don't want that in there. Why is that there? That's annoying, right? And when I'm here, if I actually just do it locally, it creates those same things. And it's just returning nothing. Why? Because this print function is actually, it's iterating through this list and it's just returning like null. It's returning nothing. And what we're getting is actually the side effect. That's what we want, is the side effect, which is the plot. Okay. So instead, what we need to do is we call walk on p $plot. We'll go 1 to 10 and then say print. Okay. So what this is going to do is it's going to apply the print function to each of these 10. Okay. So if I just do it here, I'm probably going to get nothing. Yeah, I got nothing, right? Which is like, well, that seems worthless. But when I knit it, then you can see I get just the plots without that annoying 1, 2, 3, 4. Okay. And similarly, this doesn't work if I use map. If I switch that to map instead of walk and reknit this, we can see, oh, it did work. Some bitch. Used to not work. That's, oh, no, there we go. I must have had something else in there. It's like it's repeating. Here's 1, 2, 3, 4. I'm not sure why that would be. But anyway. Okay. Does that make sense? So let's come back here. Get rid of these. Okay. We already also did this part, but in case we hadn't, we could do something like this, right? So I'm going to create a new directory. So I'll come down here. This is probably more realistic, but well, they're both pretty realistic, I think. So if I go to my files here, let me go here. I do already have a plots folder, and it's got all of that. And then I got the Pulitzers too. So let's actually just delete this for now. And then I'm going to create that directory, which we can see is here now, and it doesn't have anything in it now. Okay. And then we could create our file paths, which I've also already done previously. But I can do it here. So again, this is just going to be the newspapers is, oh, I have it final plots. Let me, what did I call it? P. I'll just call it P. P. Okay. So newspapers is just going to look like this. This is all the newspapers. again with the spaces replaced with dashes and everything lowercase. And then I'm going to create the paths, which is here, plots, Pulitzer, and then whatever the newspaper is, .png. Oops, there we go. Okay, so there's the full paths. Okay. And then we're going to walk, we can use map or walk to save these. Okay, so I'll let you go from there. You can copy and paste just like I did, but try to actually now use map to, what you're going to need, and then try to replace that with walk to and see what you see in your knitted R Markdown file. Okay, so try one and then click knit, then try the other and then click knit and see what you notice. Make sense? Okay. So if I'm here, if I've gotten to this point, I could say map to paths. And so the paths is the first thing I'm going to loop over, right? And then p plot is the second thing. And then I could pass additional arguments like width is equal to 6.5, height is equal to 9. Okay, and then I could do this loop and that's going to do what I want. But if I'm doing this on a render, oops, I forgot to actually tell it what the function was that I wanted to pass. GG save. Oops, that's not what I wanted to do either. Knit. And this is going to take a minute because it's got to go through all of these different ggplots. I probably should have limited it to only like 10 of them or something. There we go. Okay, so here it is, right? And notice it's printing all of this. It's printing all the paths. Okay, and we don't want that. So instead, we do walk to, and again, this will take a minute, but we will see that all those paths are gone. Okay, does that make sense? That's really the only difference between walk and map. However, it's a pretty important thing because if you're working with looping through plots and wanting to print them in R Markdown, walk is essential, right? So that's the reason that I show it to you. But other than that, I don't really use it. That's the only thing I use it for. Okay. All right. So we've kind of already gone through this, but map works just like walk, or walk and map are the same basically. Just like, so I'm not going to have you do the challenge part. We've already basically done it. But walk, just like map, has walk to, it has p walk, and yeah, that's it. Okay. So there's some code that you could use, and that's it. Okay, so that's it for walk. Any questions? Okay, good. Modify. Modify is also very similar to map. Okay, the main difference is that map always returns a list, right? Always, always, always returns a list. Map double always returns an atomic vector of type double or an error, right? Modify modifies the object. Okay, so if you have a data frame and you're looping through it with modify, it will return a data frame. If you have an atomic vector of type character, it will return an atomic vector of type character. Okay, whatever you pass to modify, that's what it will return to you. Okay, that same object type. Okay, so for example, if we were to loop through empty cars with map, we could use map DFR, right? But here I'm just saying as.numeric scale.x, because if you don't use as.numeric, it actually returns a column matrix. So it's like a matrix of with one column. So calling as.numeric wipes the dimensions attribute, and we just get a numeric vector in return. So if we just call map, we just get a list in return. Instead, we could just use modify, and then we get the data frame returned to us just as it was before, but with all of the scaling done. Okay, so we could also use mapdfr. I'm not sure, but I think mapdfr, somebody could try it real quick if you wanted to. But I think if we use mapdfr in this case, we would actually lose the row names. Should I try it real quick? Let's go try. Might as well. Okay, so let me do the script instead. So we'll go library, and then so if I say modify mt cars as dot numeric scale dot x, right? That returns it with the actual with the row names. Let's see if we get the same thing with map dfr. We do not. That's what I guessed. So modify actually returns the data frame with all of the dimensions and everything. We have essentially modified the data frame we had here, whereas map dfr is stripping the attributes because it's actually first making a list and then it's binding them together. Okay. Make sense? Sort of. Modify will always return what you pass it. So another example, I'm using map2 on upper and lowercase letters and pasting them together, and I get a list back, right? Here I'm doing modify 2, pasting the letters together, and I get an atomic vector back of type character because both of the things I'm passing it are of type character. Okay, that's it for modify. Again, it's very, very similar to map. There's modify 2 and p modify, I think. All right. Any questions on that? All right. So on to safely. Safely is now, so moving off of the one, so I introduced those first two first because they are so similar to what we've already done. Safely is entirely different. Okay, it's nothing like map or map2 or anything. It's actually not even really meant for iterating, but what it is meant to do is make your iterating safer. Okay, make it easier to return what you want without errors. Okay, so sometimes when you're looping through something, say you have some big list that you're looping through. It's like 8,000 elements, right, that you're looping through. There might be one specific case where you're applying this function to 8,000 different things. One specific case where the function breaks. And it works for all the rest of them. 7,999, it works great. But for that one, it breaks. The problem with the functional programming approach in that case is that your entire loop will fail. So you will get back 0 results from your 8,000. Even though it works for 7,999 of them. Okay, so that's where safely comes in to help. So very often, if you're in a case like that, you might want to do one of two things. Either you want to say, well, okay, at least give me back the output that you can, and don't break the entire loop altogether just because you failed once. However, in my experience, most of the time, what I end up doing is, okay, well, if it's failing, I need to know why it's failing. And then I need to investigate that to either ignore it or fix it, right? And I don't know what I need to do from there. So you might be able to use safely to diagnose where an error is occurring. However, as I was updating these slides, I discovered that Per has updated their error messages, and they are ridiculously helpful now, like super, super good. So this thing that I used to do with safely is probably not really needed anymore, but we'll walk through it anyway because it's still a good use case of it. So Per safely is what we're going to use for this. Okay, so please run this code to start. Okay, now we're going to try to fit a model to each of these. Okay, so I call by sil and I call mutate, and I'm creating a new column called mod, where I'm going to loop through data and apply this function, this model, where the data is .x. However, when I do that, I get an error, and so I get none of the models back. Okay, none of them. This is the part that I said is super helpful, though, with the new error messages. I'm very impressed by. It says the error occurred in group 2, sil equals 5. Let's go back here. Sil equals 5. So we know this is where the error came from. Okay. However, in some cases, in other cases, this is helpful, but I'm not, so I don't know. I could be wrong because I don't have as much experience with these new error messages. I think it's very likely, though, if you have this is about as simple of a case as we could possibly have, right? If you have a much more complicated example, it could tell you the group and where it is, and it might still be confusing, figuring out where it is exactly. So safely will for sure be able to tell you exactly where it is, and you should be able to subset your data to that one where the error is coming from. And although this tells you, it's not going to do the subsetting for you, although you could do that on your own later. Okay, but in this case, still, the point remains that it worked for 4 of the 5, but it failed for 1 of them, and we get back no results because of it. So this is where safely comes in. Okay, safely wraps any function, any function. It could be one that you wrote on your computer today. Okay, and you just call safely on that function. Safely wraps around that function, and that gives you a new function, which is the safe version of that one. Okay. Then when we're doing our looping, we're now going to loop this safe function through instead of the previous function. The syntax to that safe function is going to be exactly the same as it was for your previous function, whatever it is. In this case, we're doing lm, but like I said, it could literally be any function that exists, even one that you wrote on your computer that has never existed before 5 minutes ago. Okay, so all I'm going to do is replace lm right here with safe lm. But notice what I get back in return. Instead of getting back the model object, what I get is a named list. Okay, each of these is a named list. And that's because what the safely function will do is it will try to apply the function that you passed it, lm, right? It will try to apply that to this specific thing. If it can do that, it will put the results in a results object in the list. Okay, so it will always return a list of length 2. One will be the results, and if it can't do that, then it will return the error message that was supplied. Okay, so for each of these, one of the elements is null. Either the results are null or the error message is null. Okay, so here's an example. When I do safe models, safe mod 1, we see the result, right, and the error. Okay, so in the first one, the error is null, and we can get the model back from the result. In the fourth one, the result is null, and we get this error back instead. Okay, super useful, really, really helpful. There's another function too that I can't remember the name of, so let's go look it up real quick. We'll go to safely, the help documentation for safely, and quietly is, I believe, what it is. So let's just look down here real quick. Quietly wrapped function returns a list with components results, output, messages and warnings. Okay, so in safely will return errors and the output. Okay, if you want more than that, you can use quietly, which will also return any warning messages that occur and any just messages that occur. Okay, so any warnings or messages or errors or the output. Okay, so that can occasionally be helpful too. All right. So, as I said, I often use safely to help me debug. Why is it failing there? Right? Why is it failing in the fifth one and not any of the other ones? The new error messages help with this too. So the way that I typically do this is I first create a new variable that I can use to filter where the errors are. Okay, so for example, I can map through this safe mod object and say, give me the ones where the error part of it is not null. Okay, so this is saying, is it null? And then I'm using this to reverse it. Okay, so this is not null, basically is what this is. Okay, so this is saying false, 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 true. Okay, so the error message is not null here. In other words, there is an error message there. Okay, so I know now in the fifth one, I have an error message. Okay, so I can then from there use that column to inspect the actual data that it's trying to apply the function to and see if I can figure out what's going on. So I have my safe models. I have this part that I just walked through to get if there's an error. And then I'm going to say filter is true error. Okay, is true is a newer function from R4.0, I think. But you could actually just pass error because all it needs is a logical true or false. But that's one way you could do it. Select data and then unnest my data. So here's my cylinders, here's my manufacturer, and here's my engine displacement trans. Okay, the DISPL column and drive, this one, are constant. This is F for all of them, and this is 2.5 for all of them. So basically, we're saying, how does the number 1 relate to my gas mileage? It can't figure it out because there's no variability there, right? There's no variance, so the model fails. So this is a case where it's good to know what's going on, but we probably just want to say, okay, well, we're going to ignore that then, and we're going to just pull the results that we can. So now we're going to loop through safe mod again, and I'm going to pull the result. Okay, this, and then from here, you could actually use this to just loop through results and say is not null. That's another way we could do it. But now we have all the results, and now we could do broom tidy or whatever we wanted to do. Okay, we'd probably still want to filter it to remove the nulls from there before we did any of that. But that's an example where we use safely, we inspect the errors, we figure out what's going on, and then we make a decision from there. Either we adjust our model, adjust our whatever, something, maybe something in our data pipeline that's getting the data to that place in the first place. But then we make a decision and then we can move on and we can use the results that we have, or we can fix it and then we'll get all the results. Okay. Yeah, actually in this case, so I did go ahead and do the broom tidy, and it actually just didn't tidy the null one. So there we go. There's all the results and it worked fine. Okay. When else might we use this? Before I do that, are there questions on this at all? Okay. So when else might we use this? I've already kind of mentioned this, so I'll just say it again. Web scraping. Web scraping is not the most fun thing to do because web pages change all the time, right? So if you're trying to do something that is going to be actually like robust and will work in the future, then you've got to build into it the reality that web pages are going to change, right? So here's a very, very simple example. And I know we have not talked about web scraping, so don't worry about that part of it. However, I have rvest, which is like harvest is what it comes from. And it's meant to help do like what is called like screen scraping, right? To just grab whatever is on the actual web page. So I have two Wikipedia pages here, and then I have one that I'm just calling no such page. Okay. And this is like, if you do like serious web scraping, this is super, super common, right? Like I helped a student during her capstone do this, where she went into a specific newspaper and got all of these links for different editions and different articles and stuff. And then she wanted to loop through all of those to pull as much as she could from each of those pages. Okay. But she either forgot about it or whatever. She forgot about safely, I guess. And so she was like going through and scraping like the first 50, and then it would work. And then she'd save it and then scrape like the next 50 and it wouldn't work. And then she'd go back and do the next 30 and then like it'd work. And then, you know, like that really takes forever, right? If you have like thousands of pages that you're going through. So instead, you need to use safely. So here's a very quick example, right? So I'm going to loop through the links. I'm going to do this sys.sleep to make it pause a little bit in between each one, because you don't want to overwhelm a web page by going, right? You want to pause and do it a little bit slower so that you're not overwhelming web pages. And then I'm going to say read html.x. And so it's just going to read each of these pages. However, when I do that, I don't get anything back at all, right? Because it couldn't connect to this one. So because it can't connect to that one, I get no results back at all in my thing. Okay, so I can't connect to no such page because it obviously doesn't exist, but that also means I can't get any of the links, which is very frustrating. So it's not a big deal if it's 1 in 3, but obviously it is if it's 1 in 1,000 or more. Okay, so safely helps here. So we call safely on read it HTML, and we have this new one called safe read HTML. Everything is the same in this part, except I'm now using safe read HTML instead. Okay, and then when I look at the structure of this, the first one is a list of 2. It's got a result. Here's some stuff. Error is null. On the second one, the result is null, and we have this error message. And then on the third one, we have a result, right? And then the error would be null, although it's cut off here. Does that make sense? Any questions with that? Safely is very, very useful and highly recommended. So we do probably always generally want to inspect why we're not getting results when we're not getting them. But so this is one way to do this, right? Map logical, go through and see if it's an error, and then links for the errors. This would give you the links to the ones that have the errors. Okay, just a couple more, and then we'll get out of here. We got about 15 more minutes. Okay, and we probably won't need that all 15 minutes. So reducing a list. Okay, so map always returns a vector of the same length. So if you loop through a vector that has 7 elements, you'll get a list back that has 7 elements. Okay, reduce works differently. It takes the first element and then it applies that function, the function result from that first one, to the second one, and it computes that result and applies that as the like starting value of the next one. Okay, and so when you're applying reduce at the end, you will always have something of length 1. Okay, because it's going to collapse the list to length 1. So this is a very, very, very simple example, which you would probably never do, but it does show you what reduce is doing. So we have 1 and 3, 1, 5, 7, and 9. 3, and 4, 8, 12, and 2. Okay. If I call reduce on this list and I say sum, it's going to collapse across the list and sum all of the elements. Okay. So this is equivalent. Well, hang on first. If I do the same thing with map, you will see I get each element is summed, right? So I get the sum of this one, 4, and then I get the sum of this one, whatever that is, 22, and then the sum of this one, 3, and then the sum of this one. Okay. Reduce works differently. It works like this. Okay. So we have 1 and 2. It's going to sum those. And then it's going to take that result and sum the third one. And then it's going to take that result and sum the fourth one. Okay. So slightly differently. Take the first sum, then the second sum, where notice first sum is the first element in sum here now. And then this is the second sum, that becomes the first element in this sum, and then we get our final sum. Okay, so that's what reduce is doing. Why might we do this? Like I said, there are use cases for this. I just had a hard time coming up with great ones while I was trying to come up with these slides. So this is not like a topic that I've lectured on a bunch in the past. That's part of the reason probably. I have introduced it before, but I think only once before, and I couldn't think of any good examples then either. But here is one, I think, decent example at least, which is, imagine we have a list of data frames, okay? And those data frames have this ID column that is in common with them. So they can be joined. However, everything else on them is not the same. So we have ID and score, ID and treatment, and then ID and other thing. Okay. So I could join these together manually, right? I could take the first one and join it to the second one, and then take that result and then join it to the third one. Or I could use reduce. Okay. So I can reduce LDF, my thing, what I called back here, right? LDF. I can reduce that and then apply a join function, full join. And, you know, because of the way dplyr works with its joins, it's going to figure out that ID is the common column, and it's going to join by ID. And we get all of those joins. In this case, it's only 3, so it's not a big deal, but it could be 7 or 17 or 77. And it joins all of them in one step. Okay. You do have to be a little bit careful with this though on directionality. So if I call LDF and I call left join, I get 1, 2, 3. If I call right join, I get 1, 3, 5, 7, right? Because it depends on how this thing is sort of going together. Think again about that sum, this one, then this one, then this one. So thinking about which is the left versus the right data frame. That's why I started out with a full join. But as I've sort of mentioned in the past, full joins are most of the time not what you want, actually. Left joins are almost always what you actually want, where you have a primary data frame and you're adding stuff to it, rather than saying, just give me everything of everything, because then you end up with this massive unruly data set. Okay, one more example. So this is a case where all of the columns are the same. And then you could say reduce LDF to bind rows. However, this one has become obsolete because bind rows will do that for you. So you don't actually have to do reduce on bind rows. If you have a list of data frames, you can just pass that directly to bind rows and it will do it. So, but it's still worth thinking about, I think, that reduce is what's happening under the hood of bind rows when you pass it a list of data frames. Okay, yeah.
For reduce, can you use the arguments that are contained within the function?
Yes.
Okay, great.
Yep. They are just, I think it's just a ... additional arguments passed to the function. Okay, and then one last example. This is a terrible example, but there are use cases that are very much like this, okay? Where there's certain rows that I want to bind together and like paste them together. So here's an example where I'm looping through penguins and I'm calling as.character. So every column of penguins becomes character. And then I'm going to reduce that and paste it together. So what I'm getting in return is all of the data as a single string for each row. Okay. And so there's many cases where you might have like a first and a last name or something like that, and you want to just put them all together, and you want them outside of your data frame now. You just want a vector of names, right, that you can do something with. That's where reduce could be helpful, where you can pass some things and it's going to paste them together like that. Okay. So this is just to kind of say, I use reduce a fair amount, but as I mentioned, it is kind of hard to come up with examples for it. When I say a fair amount, I would still say it's like maybe 1 out of every 10 times that I use the other looping functions I've talked about. Okay, so it's not like a super, super common one, but it's still absolutely something that I use, and it's good to, again, just have more strategies to approach this stuff because it's difficult stuff. Okay, so wrapping up, there's lots more to per, but we have covered a lot. We've covered a lot, not only just on looping, but on per specifically. Functional programming is super, super helpful. And I do think if you force yourself to try to think in a functional programming way, and then actually apply these tools, it will initially slow you down, right? But in the long run, it's going to make you have better code that's more robust, that's more efficient, okay? And to me, this is very much along the lines of, like, if you think of your R learning curve, right? At first, it's like this crazy uphill battle to just get anything going, right? And then you get pretty functional. And at least for me and most of the students I've observed anyway, you kind of reach this plateau where you're like, okay, I can do a lot of stuff and I'm able to, get done what I want to get done. Functional programming is sort of that next step. Okay, it's sort of the next thing that takes you from moving out of that plateau and into really efficient, amazing code. Okay. All right. So we don't really have time for anything else. We'll just break a few minutes early. So just one more reminder, next time is fully remote. You should be able to come to class if you want to, but you can do it from wherever you want. I will be in Chicago, so that's where we'll be. For the midterm and everything, please do get in touch with me if you have any questions. If you want to hang around here, I'll stay around for the next couple of minutes if you want to ask any questions on that or anything else. Okay.